I hope you all doing great. So, welcome to the class. Welcome to EDS online education multi education platform. Yeah. So before starting our session, let me introduce myself. I'm Uday Kiran. I'm your maths academic specialist. I'll introduce our features and tools you have. So you have chat option with you in the live session. So you can interact with me through chat with the live teacher. So in the live session, you have expert tutors are there. So you can ask your doubts and clarify your doubts accordingly. And after the class, you have recording sessions and exam preparation materials also there. So you just try to revise all the topics. If you couldn't understand the topic, just watch the recording sessions. Okay. Yeah. In the previous class, we just end up with the real numbers. Now the next chapter would be polynomials. In the polynomial, we have to discuss a lot of things in the polynomial, and this is exam in exam, so it was weightage would be high. Okay, so that's why you have to understand and prepare well for the polynomials. So only, my request only for you is to pay attention in my class and try to learn something. Okay, so that is the only request from my end. All right, so yeah, let's get start our session, guys. Okay, today we are going to start polynomials. In polynomial, let's understand the polynomials what we have discussed in the previous classes, previous grades. I mean class 9. Okay. Yeah. Here in the class 9, you have learned about polynomial in one variable and their degrees. Polynomial one variable is nothing but try to recall. So polynomial equation P of X with highest power of X is nothing but degree is nothing but the highest power of the polynomial equation. I think everyone knows it, right? Degree is the highest power of the exponent of the polynomial equation. Here, example 4x power 2, 4x plus 2. What is the degree? Observe the x variable x power. So that is 1. That is why the degree is 1. And coming to 2y square minus 3y plus 4. Observe the highest exponent. First, you just observe the variable. What is the variable here? Y is the only one variable. Y is the only one variable. And observe the power. Power here 2 when 1 and 0. 2 is the highest degree. That's why, I mean, highest exponent. That's why it is a degree of that polynomial. And coming to 5x cube minus, so there are a lot of examples are there. So you just identify and yeah, how can you define the polynomial whether it is a polynomial or not? Okay, let's understand what we have discussed in the previous classes. Okay, yeah. So in the previous class, first of all, I'll explain what is polynomial. Then we can go by step process. Don't worry, I'll explain each and every word. Let's take an example of polynomial. Okay, 5x cube let's take 5x cube minus 3x square plus 2x plus 5. First, you need to identify, understand about the what are the terms in the polynomial. Okay, the terms here are here variable is only one. So variable is x. X is the only variable throughout the equation. Okay, here minus plus all these things we call as operations. All right, and 5 here is the coefficient of x cube. Once again, coefficient of x cube, and 3 also coefficient, 2 also coefficients. Okay, and here is 5 is constant. 5 is constant. Anything else we left with? Okay, so here we can classify the polynomial equation. One second, guys. Okay, now it is perfect. Okay, so 5x cube minus 3x square plus 2x plus 5 is equal to 0. So you just identify what are the coefficient and variable. I just rewrite once. Coefficient. Okay, coefficient. What are the coefficients here? Can I take 5 as a coefficient? No, 5 we called as constant. 5 we called as constant. Constant is nothing but non-zero term. Okay. Let's write the exponent. Yes, that is what I missed. Exponent. exponent, or else power, whatever the word you want. So this is also power, and this is also exponent are there. Exponent or power, whatever the word you have to use. Let's write the exponents here. Exponent or powers. Exponents. Exponents are would be here in the question. 3, 2. Here x cube. Cube is nothing but 3, and x square 2. And if nothing else, you can take 1 here. That is 1. 5 into, observe carefully, guys. This is the mistake everyone doing. I'm taking exponent 0 also. Sir, why, sir? There is no x variable is there. So how can you take 0? Let's understand. 5. 5, we can write 5 into 1. 5 into 1. Everyone agree with me? 1, can we write like x power 0? Can I write like x power 0? Why? Because in the law of exponent, the lower grade, we learned about a power 0 is equal to 1. A power 0 is equal to 1 from law of exponent. All right. That's why 5 into x power 0. Now, if nothing else, you can take x power 0. Now, what is the exponent here? I mean, x power. What is the power here? 0. So 0 is the one of the variable. Sorry, 0 is the one of the exponent. I hope everyone understood till here. Yeah, first one is exponent, and only one variable here. Variable here. Let's write the variable. Variable throughout the equation is x. Variable throughout the equation is x. Okay. Constant here is 5. Constant here is 5. Okay. I hope everyone understood. So how can we conclude that? How can we conclude that? So let's understand carefully. Yeah. So now we can confirm that as the polynomial general form. Let's write the general form. General form or standard form? General form or standard form of polynomials. What is the general form? Anyone knows? I just write it here. Yeah, general form would be ax square plus bx plus c. Ax square plus bx plus c is equal to 0. Okay. Yeah, the quadratic polynomial in the equation. So moreover, so we have to write ax square plus bx plus c, or else whatever. If you want to write in cube, so it's up to you. Simply you can take ax cube plus bx square plus cx plus d also. You can take a general form. All right. So depend on the question. Depend on the type of polynomial you are taking that. Here I'm taking this, and now the condition would be, conditions are really, really important. Here a, b, c are real number. A comma b comma c are real numbers. I think everyone knows the real numbers, right? It is a combination of, it is a combination of rational number, irrational number, and a not equal to 0. This is the second condition. First condition, second condition. All right. A not equal to 0. Anything we left. Okay, so these are the basics. If I ask you, I'll check. Let me check. Okay, that's it. So that is the basics. So if I ask you what is the general form of the polynomial equation, you can tell like this: ax power n plus bx plus bx, and like this: bx square plus c is equal to 0. And these conditions are really important. A, b, c are for real numbers, and a not equal to 0. All right, a not equal to 0. So these are the basics. And if any equation, you can describe like this: coefficient is first one, and exponent is the nothing but power. And yeah, I missed one statement here. The third condition here is, the third condition here is exponent. Exponent is every time a whole number. Exponent nothing but, okay, just write exponent or power. Some people like the power is the word. Everyone remember it. So power or else exponent, whatever the word. Okay, it would be whole number. What is the whole number? So that is 0, 1, 2, 3 till so on infinite. So power, it is not in terms of negative. Remember that. So this is really, really important. This the third condition. Exponent is a whole number. Exponent or power is a whole number. Sir, what is this exponent whole number, sir? Exponent here is 3, 2, 1, I already rated here, 3210. So these are the exponent. So observe here, these are the whole numbers or not? These are the whole numbers or not? So whole numbers are started from 0, 0, 1, 2, 3 till infinite. So these are the whole numbers. Okay. All right. Okay. Let's start it with the why, because the you should be strong in basics, guys. That's why I'm stressing all these points. Okay. I'll give you, for example, I'll give you one equation: 2x cube plus 3x square minus 5x plus 6 is equal to 0. I'll ask you, state whether it is a polynomial equation or not. True or false? State whether it is a polynomial or not. Okay, I miss n. Polynomial or not. Find the answer. How can you describe? So first step is you just write the exponents. Exponents. Here exponents is nothing but power. 3, 2. If nothing else, you can take 1. So it is invisible. I already told you. So 6, you can write it as 6 into x power 0. Now what is the exponent here? 0. So you can write 3, 2, 1, 0. Okay. Exponent every time would be whole number. Observe the numbers here. All are whole number or not? All are the whole number. That's why we can confirm as. And polynomial. Okay, once again. Yeah. So polynomial. Here we discuss about polynomial. About that. So these are the conditions, and observe the variable x or not. Okay. These are the condition, and I'll give you another question. Try to solve this one. For example, let me take mm, what I have to take. Okay, I'll take 2 by 3 comma y plus 1. Now it is polynomial equation or not? 2 by 3 into y plus 1. Oh, only thing is you just observe the exponent. Write the exponent here. Exponent where we have to identify the exponent. Observe the variable. Variable here is 5. So power is 1. Sir, 2 by 3 is there, sir. So 2 by 3 is a coefficient of y. So we are not include that. We are only seeing the powers. So y power here is 1. The exponent here is 1. So that is why it is a polynomial. Okay. I'll give you another question. Third one. Okay. 2 by x. 2 by x plus 3. 2 by x plus 3. Is that a polynomial equation or not? Think about it. Think about it. Here 2 by x plus 3. So x is the at bottom, I mean the denominator. So we have to transfer in the numerator like 2 into, can I write like this? X power minus 1, x power minus 1 plus 3. I just transferred to numerator, it become x power minus 1. Now write the exponents here, exponent or else power. Here power is minus 1. What I told you. So exponent is a whole number. Minus 1 is a whole number? Not. So that's why the given equation is not a polynomial. I hope you understand how you check whether it is a polynomial or not. Or let's say, shall I give you another example? Let's understand here. Yeah, here they given 1 by x minus 1 root x. Yeah, that's a good point. Let's check root x. Okay, I just write it here. Root x plus 2x square plus 3 is equal to 0. Check whether it is a polynomial or not. Okay, I just rewrite it as root x. Can I write like x power 1 by 2 and 2 into x square plus 3? All right, I just rewrite it like this, the equation. Now observe the exponent. Observe the exponents here. What are the exponents here? Here exponent is 1 by 2, 2. Here nothing else, you can take 0. So 1 by 2, 2 and 0. What I said, exponent is every time would be a whole number, whole number. But here, observe carefully, 1 by 2 is nothing but it is in the form of p by q. P by q, it is nothing but it is a rational number. It is a rational number. Okay, so that's why. So it is not a polynomial equation. Root x plus 2x square plus 3, it is not a polynomial equation. Why? Because root x, we can express it as x power 1 by 2. X power 1 by 2. Whole number. So that is 0, 1, 2, 3, only positive numbers starting from 0 till infinite. I hope you understand. So in the previous one, it is not a polynomial. Why? Because power minus 1 is there. Power minus 1. Now here it is in the form of p by q. P by q. So it is as a rational number. It is not applied in the condition of whole number. That's why we just eliminated like this. Yeah. So these are the examples. Some of the examples they given. Okay. They are not polynomials. 1 by x, 1 by x, 1 by x minus 1, root x plus 2. Just now we discussed 1 by x square plus 2x plus 3. Okay. All are the not polynomials. Okay. All right. Let's move on. Hmm. Okay. Now next concept would be types of polynomial. Okay. Next concept would be types of polynomial. First class is very, very important. I'm teaching all the basics about the polynomial. Try to take the notes, those who don't know. Types of pure polynomial. The first condition here is based on based on degree. Based on degree. I think everyone knows what is degree, right? Based on degree. So the first one is uh okay, if degree is one, if degree is equal to one, then we call it as linear polynomial. Linear polynomial. For example, let me take one example here. Let's take example. Example is nothing but x plus 1. Here degree is 1 and y plus 1, y plus 2 like this. You can take any examples. Okay, second one, if degree is 2, if degree is 2, so we call this quadratic polynomial. Quadratic polynomial. If degree is, okay, I just write the examples for your reference. Let's write the example. If degree is 2 is nothing but, so you have to take the power would be 2. So x square plus 3x plus 4, or else minus y square minus 2y plus 6 is equal to 0. So these are the examples for uh, quadratic polynomial. Now the third one is if degree is 3. If degree is 3. Okay. So we call as cubic polynomial. Cubic polynomial. Understand? Examples would be x cube plus 3x square minus 2x plus 5. Here the highest power would be 3. So that's why you can write the degree of cubic polynomial like this. Okay. Yeah, you can take any example. It's up to you. Okay, I'll ask you one simple question. What if degree is 0? What if degree is 0? As we know in the textbook, they given yeah, linear polynomial. If the a polynomial of degree is 1, we call as linear polynomial. These are the example 2x minus 3, all those things. All right. And yeah, a polynomial if degree is 2, we call as quadratic polynomial. Okay. So quadratic polynomial, the examples, if you observe carefully, all the examples they given. And for cubic polynomial, a polynomial of degree is 3. So we called as cubic polynomial. They already given the example 2 minus x cube, only x cube. Yeah, we can write only x cube here. Only x cube also degree, highest degree is 3. Okay. And minus 3x square like this. A lot of examples they given. Okay. And anything else? Yeah, there is nowhere mention about What if degree is 0? In the textbook, they are not mentioning anything, so we call as constant polynomial. We call as constant polynomial. Okay, if degree is 0. Sir, what is the degree 0? How can we take an example? So let's take an example. The number 2. Number 2. What I told you at start? Sir, there is no variable. So how can we describe the degree here? Observe the variable here and what is the highest power. But is there is no variable x or y, a, b, c or anything, then how can you say degree is 0? You can generate expo. Can I write expo 0? Right? Expo 0 is nothing but 2 into 1. Expo 0. You'll get 2 again. That is the question, and you can rewrite it as there is the space is there. You can write it as x power 0. Okay, now degree is 0, so that is why the constant polynomial. Or else you can take okay, yeah. So you can take that example like this. Okay, let's move on. Okay, zeros of polynomial. I think already you people learned at lower classes. I mean, ninth class, right? Okay. Now the next concept would be okay. Zeros of polynomial is nothing but let's understand about zeros of polynomial. Let's understand zeros of polynomial. Where is that? Zeros of polynomial. So I'll tell you with the example, guys. Don't worry. So here, when polynomial equation. So here the definition in the given. Let's understand the definition. Yeah, zeros of polynomial p of x when p of x is a real number k, and yeah, the polynomial if you divided with the polynomial equation p of x, uh, here if you divided with x minus a, or else x minus a is a factor for that polynomial equation, then you should do the first step is you should make p of x is equal to 0, that is x minus a is equal to 0. Now x is equal to a, x is equal to a. Now the polynomial equation it become p of a is equal to 0. P of a is equal to 0. Hope you understand. I'll give you one example for your reference. Let's try with the example of 2x square. Okay, polynomial equation p of x is equal to 2x square plus 3x plus 5. Okay, at divide with the factor they given x minus 1. X minus 1. Now how to do this? The factor is x minus 1. You should equate to 0. You should equate to 0. X minus 1 is equal to 0. Now x is equal to 1. Substitute x is equal to 1 in this particular equation. If you see in anywhere 1, sorry, x, you just substitute 1. 2 into 1 square plus 3 into 1 plus 5. So 2 into 1 square is nothing but 2. 2 plus 3. 2 plus 3 plus 5. So you'll get, so 2 plus 3, 5 plus 5, you'll get 10. So you just substitute like this. First step is very, very important. X minus a is equal to 0, then x is equal to a. So that is the thing we have learned in the previous classes about zeros of polynomial. Okay, about zeros of polynomial. Now, but in this grade 10, so you need to understand how you just represent the zeros of polynomial in geometrical representation. How can you find the zeros? How can you find the zeros? So here, first we'll see the geometrical representation of linear and quadratic polynomial, and we'll find out how to find the zeros. Zeros is nothing but roots, x comma y, all those things. Okay. Okay. In the ninth class, what we discussed in the equation y is equal to 2x plus 3 is a straight line. Here, y is equal to 2x plus 3 is a straight line. Uh, okay. Once again. Minus 3 comma 2 is the 0, and Yeah, in the ninth class, what we discussed, if they given polynomial equation like this, y is equal to 2x plus 3. So you can assume the x value is 0, then you will get y value. And you can take y value and alternatively you'll get x value like this. So you're generating the graph like this. After taking some assumption, you will get the graph like this. You have to represent the graph and where the x-axis is touched. So we called as zero of the polynomial. We called as the zeros of the polynomial. This is what we learned in the previous grades. Now we in grade 10 we have to represent. We don't solve like this all the sums because it is lengthy method. How can you find the zeros? By seeing the graph. Observe here the corresponding graph. In the corresponding graph, ax square plus bx plus c, ax square plus bx plus c, the two shapes, it look like U, okay, upward direction. Shapes open at upward direction, open at downward direction. It depend on the, it look like a parabola or else curve. After taking the point and substituting over there, I'll get the point like this. Okay. So here we need to identify like, yeah, in case one, how to find the zero. Observe carefully. The graph cuts x-axis at two distance points. How to find the zeros by, yeah. So in fact, observe the statement here. The true fact is that, so in fact, this point is important. So the parabola intersect the x-axis, cut the x-axis, simply cut the x-axis. I hope you understand. Let's observe that. Observe the case one. In the case one, here the graph cut x-axis at 2 points, a and a dash. That's why the zeros are 2. Here it was meeting at the x-axis. Let's try with the one problem here. Mm, Once again. Okay, no shapes around. Let's see. If I take some random graph here, let's take some random graph. Okay, I'm sorry. Uh, Still it was 1 second, guys. Let's take one random graph here. Okay, this is x-axis and y-axis like this. Ignore the diagram. For your understanding, I'm solving this one. Okay, x-axis and y-axis. Okay, you'll get the graph like this. You'll get the graph like this. Okay, and identify the graph here is, let's take y is equal to 2x square plus 3. Okay, this is the graph. After taking that, after substituting all the values, you'll get the graph like this. Observe carefully here at what point. So this is the x-axis. This is the x-axis where it was touching. Here touching at 2 points. The curve, it is touching the x-axis at 2 points. So that's why zeros, the number of zeros we have to take 2. Simple, right? So that is what they are doing here. Observe the textbook here. The case one, the graph cuts x-axis at two distance point. Here the downward curve, it touches the x-axis at this point and this point, a and a dash, and here also it is touching at a and dash. That's why. So it has two zeros. The quadratic polynomial, it has two zeros. Let's move on to the case two. The case two graph. Here the x-axis, it cuts the x-axis. The graph cuts the x-axis at exactly 1 point. Observe the 1 point here. Here is the point A. Okay, and here is point A, the upward direction, downward direction. Okay, so the number of zeros would be 1, only 1 0 for that particular graph. The graph is either completely above graph is either completely above x-axis and completely below y-axis. Okay, completely below x-axis. In that case, it is not cutting or touching any x-axis here, let's take the graph here like this. I think already you people understand, but let's understand. Here the graph, it's look like this or else like this. It nowhere touching at the x-axis, nowhere touching the x-axis. This is x-axis. So that's why the number of zeros would be, number of zeros is 0. I hope you understand. So it does not cut the x-axis at any point. The number of zeros you have to take 0. All right. Now you are able to do the exercise part some sized. Okay. Let's start with one example, whatever they given here. Example one. Example one. Try to identify the example one. Here it was cut. Okay. It was cut the x-axis. Look at the graph here. It was cutting the x-axis at one point. Here is the point. Here is the point, exact point. Okay. So that's why it is the number of zeros is 1. Let's see the answer. The number of zeros is 1 as a graph cut the x-axis at one point. Similar way, the second graph, here it was, once again. All right, here is the graph cutting it at 2 points, 1, 2, 1 and 2 here, 1 and 2 here. That's why the number of zeros would be, the number of zeros is 2. Okay. Why? Because the the graph cut at x-axis at 2 points. And the third one, 1, 2, 3. I hope everyone identified what I'm doing now. So 1 and 2, 1, 2, 3. I just draw the graph here. Let's clear this one. Okay, no need to clear. Let's take the some raw graph here. Okay, so what I'm saying that, so x-axis here, so it was cutting at the x-axis like this. If they given graph like this, and how many point is it touching the x-axis? So this is x-axis, 1, 2, 3, 4. Now the number of zeros would be 4. So zeros would be 4. All right. The same equation they given 1, 2, 3 here. The number of zeros is 3. 3. All right. Now fourth one. Fourth one, the number of zeros is 1. Why? Because it is cutting at the x-axis at one point. Fourth graph, fifth graph. Observe that only 1 point. Only 1 point. So that is the fifth one also 1. And the fourth one, just now I draw that 1, 2, 3, 4. 4 point it was located. That's why number of zeros is 4. All right. So you just find the graph like this. I hope you understand. Now that's it. The first exercise is nothing but the simple one. So you need to identify the graphs. Now read the question, exercise 2.1. Let's start with exercise 2.1. Identify how many at how many points the graph would be touched there. So here the first graph, then you can find the number of zeros like this. The first graph, is there any we're cutting the x-axis, the graph cutting anywhere x-axis? No, right? No. So that's why. So the number of zeros is 1. Let's start with exercise 2.1. Exercise 2.1. 2.1, right? Yeah, 2.1. Let's start with the first one. First one we got already. Okay, so the first one there is no cutting of x action, so number of zeros is 1. Second one, here the it is cutting at exact at one point, so zeros is, okay, first one is 0, I'm sorry. So zeros is, number of zeros is 1. Third one, it is cutting at x-axis at 1, 2, 3. I'm sorry. So here, the third one, it was cutting at x-axis at 3 points, 1, 2, 3. So that's why the number of zeros is 3. Okay. Similarly for fourth one is cutting at x-axis 2 points. Number of zeros is 2. And here 1, 2, 3, 4. 4 points. Fifth one. Fifth one. That is zeros are. Zeros is equal to 4, I think. 1, 2, 3, 4. And the sorry, fifth one, right? Yeah, sixth one, 1, 2, 3. So sixth one would be 3. Number of zeros is 3. You just write like the y of x, y is equal to p of x is the graph. It is cutting at the x-axis at 1 point. Then you can write like this. Don't write like the zero is the number of zeros is 0, the number of zeros is 1. You don't write like this. You just write in words. All right. So that is our first concept. Okay. Next concept. How to find the number of zeros and everything. Okay. Mm. Next concept is relation between zeros and coefficients. Zeros and coefficient is nothing but, let's understand what they are mean. Coefficient is nothing but if you take 2x square plus 3x plus 3x plus 5, coefficient is nothing but x square coefficient here is 2, x square coefficient is 2, and x coefficient is 3, and constant, there is no x variable, that's why the constant is 5. The constant is 5. You can take like this. All right. I hope you understand. Yeah, so that is the relation between x coefficient and x square. Here in the previous classes we learned about factorization method. While they given the equation, any equation, you just do the factorization method. I hope everyone knows how to do the factorization method. Everyone knows, or else shall I explain it? Why? Because in this chapter, the polynomial equation, we have to factorize the polynomial. That is why the factorization also you need to splitting middle term. Simply splitting middle term is also important. All right. Okay, let's understand. First, I'll explain factorization method. Why? Because you people, yeah, let's try with the one question. 2x square minus 8x plus 6 is equal to 0. I'll explain step by step one, guys. Those who don't know how to do splitting middle term. First, you just write ABC value. A is equal to 2 here. A is nothing but, okay, first you need to compare with the general form. What is the general form? Ax square plus bx plus c is equal to 0. Identify ABC value. In the place of a, what is there? X square coefficient. X square coefficient is 2, and x coefficient is, you can take symbols also, -8, and constant is 6. Constant is 6. So this is our first step. I just write the first step here. First step, and yeah, next step is step 2. Step 2, you need to multiply. Okay, not multiply. Product of A into C is matched or equal to equal to B, equal to B. What is this A into C? So here we are doing splitting middle term. What is the middle term here? B, that is -8. Whatever we are taking A into C, that is 2 into 6. Let's try with the 2 into 6 here. A into C. That is what I'm saying. 2 into A into C. 2 into 6, you'll get 12. Write the factors for 12. I just start from one table. 1 times 12 and 1 times 12. Observe carefully. The Here we have 2x square minus 8x plus 6. The middle term we are splitting. What is the middle term? 8 is the middle one. 8 is the middle one. So whatever the factors we are taking, 112. If we add 1 plus 12, we'll get 13. It is the doesn't match with the 8. If we subtract 12 minus 1, we'll get 11. So it doesn't match. That's why we cross this one. That's why we just cross 1 and 12. 1 and 12, it is not suitable. Let's try with the 2 and 6. 2 plus 6, 8. It is matching, right? So we have to take 2 into 6. 2, 6. Let's write it here. The question 2x square minus 8x plus 6 is equal to 0. You should equate. That's why I'm writing that it is matched or equal to B. It is equal to B. Okay. All right. 2x square 2x square minus 8x minus 8x. We are splitting the middle term, right? It should be matched with 2x. We the factors would be 2 and 6. You have to take 2 and 6. You just adjust like this. Can I write minus 2x minus 6x? Can I write like this? I'm doing only the splitting middle term. That's why I change the color accordingly. Okay, minus 8x I splitting. That's why I write it as minus 2x minus 6x. I hope everyone understood. Agree with me? Okay, now you have to take common from these two and these two. First two and first two. Let's do it in the next step. Next page. 2x square minus 2x minus 6x plus 6 we got is equal to 0. Now we have to take common from these two, these two. Sir, we are not able to take common. So how to take the common? I'm here to help you. Let's do it in the rough work. 2x square. 2x square. How can you split? 2x square. First, if nothing else, you can take plus here and 2 here. X is 2 times. X is 2 times. X into x, right? And minus 2x. You just write the symbol here minus 2 here and x here. Now you can take common. Plus and minus both are different. We can't take common. 2 is the common from these two, and x is the common. X is the common. All right. So that is why you have to take 2x as common outside. And what you left with after taking the common, plus is there and x is there. So you left with inner bracket x. And here minus is there, x is there. Sorry, already we taken x, right? So if nothing else, you can take minus 1. Symbols also really important. That's why I'm mentioning here symbols also. I hope everyone understood. So this is the rougher part. If you are master in it, how to solve the splitting middle term, then you can do it. Though I'm saying for beginners, okay, those who don't know how to take the common. Now minus 6x plus 6x. Minus 6x, so minus comma 6 comma x plus 6 plus and 6 is and 1. Here 1 is the invisible number for both. So that's why I'm writing 1 also. Okay, now let's take the common. Minus plus both are different. We have to don't have take common. And 6 is the only number here and 1 is another number here. Okay, so let's take minus 6 here. So what we will get? If you take minus 6 here, okay, once again I just change the color. Minus 6. All right, minus 6. I'm representing with the colors, guys. Try to understand. After taking minus 6 as common, what you left in the okay, minus also we taken common, and what you left? X and 1 here. So x minus 1 is equal to 0. Okay, now what is common here? X minus 1, x minus 1. Let's take x minus 1 as common. You left with 2x and minus 6. 2x minus 6 is equal to 0. Now you should equate x minus 1 is equal to 0 and 2x minus 1 equal to 0. X minus 1 is equal to 0. 2x minus 6 is equal to 0. Transfer 1 to other side, you will get x is equal to 1. Transfer 6 to other side, you will get x is equal to 6. Now x is equal to 6 by 2. 6 by 2, that is 3. Okay. Now both value x is equal to 1 and 3. I hope you understand how to find. All right. All right, let's move on. Yeah, you just find the factors like this. So you'll get x is equal to 1 and x is equal to 3. Yeah, these are the steps. First step is step 1, step 2. Okay, this is the step 3. I just write the step 3 here. Yeah, this is the step 3. Okay. Step 4. Step 4, you have to take common. Step 5 is nothing but you just write the x value. X is equal to 1 and x is equal to 3. All right. This is for rough part I'm giving to you. If you want to do the rough part like this. Okay. All right. Okay. Now the next concept would be sum of zeros and product of zero. I'll give you a brief introduction. Then we will start. Okay. Sum of zeros. Let's write the equation. Ax square plus bx plus c is equal to 0. This is our standard equation, standard polynomial equation. Here, sum of zeros. Okay, we don't know the zeros. Let's take, let, okay, let alpha and beta are two zeros. two zeros. All right. Now, yeah, now sum of zeros. First one is sum of zeros is equal to minus b by a. What we call minus b by a is nothing but we have to write minus of b here is there. So minus of coefficient of x by coefficient of x square. Coefficient of x square. Try to take the notes, everyone. Coefficient of x square. Now let's coming to now next product of zeros. Product of zeros. Or else simply you can write it as the two zeros we have taken alpha beta. The sum of zeros is nothing but alpha plus beta, and product of zeros is nothing but alpha into beta, alpha beta. Okay. Product of zeros is nothing but c by a. C here is a constant term. The constant term, the constant term by coefficient of x square. Coefficient of x square. Okay. So this is the formula and very important point. And if they give an equation, so you just find like this. So this is the sum of the zeros and product of zeros. Okay. Let's understand with one example. Sum of zeros is nothing but minus b by a. Let's start this. All right. So I'll give you one example. 3x square plus 5x minus 2 is equal to 0. Now find sum of zeros. How to find sum of zeros? Sum of zeros is nothing but alpha plus beta is equal to minus b by a. And product of zeros, alpha into beta is equal to c by a. Sir, what is this minus b by a and all those things? I'm here to help you. So x square coefficient. So what is a here? A is 3 and b here is 5 and c here is minus 2. Okay. Let's substitute all those values here. Minus b by a is nothing but minus 5 by 3. C by a is nothing but you can take symbols also. Minus 2 by 3. Minus 2 by 3 is the answers. Okay. So this is how you should find the sum of zeros and product of zeros for all the equations. Okay. Yeah. Tomorrow we'll understand the deep analysis of yeah, this is alpha plus beta is equal to minus b by a and alpha into beta is equal to c by a. That is what we write it here. Okay. The Greek letters are alpha and beta. So we have to use gamma for cubic polynomial. Yeah, this is the formula. Coefficient of x by minus coefficient of x by minus coefficient of x square like this. Okay. Tomorrow we'll start exercise. The next class we have to start example sums and also we'll understand the what is the standard form of the quadratic polynomial, the relation between coefficients and zeros. Okay. Yeah. I just stopped it here. Yeah. Thanks for being here, everyone. So let's meet on the next session with another concept of relation between coefficient and exponent, and we'll solve example sums. Also, we'll complete the exercise sums if possible. Okay. Before that, while coming to the class, try to do one thing. You just revise all the topics what we have learned in the previous class. All right. Yeah. Bye everyone. Yeah. Let's meet on the next session. Have a good day.